On this question, we want to find the domain of the function f of x equals square root of 2x minus 18. When you're looking for the domain, you're looking for possible restrictions. And in this example, I see a square root. And with square roots, we know that square root of a positive number is a real number. We know that the square root of 0 is 0, which is a real number. However, the square root of a negative is going to give you I, and that is a complex number or imaginary number. So this gives us a restriction on square roots, and that restriction is that we only want to have positive values or 0 values, or we can say non-negative. So I've got some information up here being more specific about radical and root functions. This is obviously a radical or root function because we have the square root. And with radical and root functions, you want to pay attention to whether you have an even index or an odd index. So the index is going to be on the radical right here. In this example, we don't have an index listed, and when an index is not there, we assume it to be a square root. And so we're dealing with an even index. So here's a definition of a root function. A root function is of the form f of x equals the nth root of g of x. And this is when n is an even positive integer greater than or equal to 2. So that's when we have an even index. And when that index is odd, then we have an odd index radical. So what's interesting about the difference between even index and odd index is that it doesn't have the same restrictions. If we have the nth root of a negative and n is odd, that is a real number. So it's only when you have the even index of a negative that produces a complex or imaginary number. So in this example, this is what we're going to follow to find the domain. So taking the even root of a negative number results in a complex or imaginary number. Since we're interested in real function values, we would like the expression inside the radical to be non-negative, 0 or positive. We're going to create an inequality to solve, and that inequality is the expression underneath the radical greater than or equal to 0. So we've made g of x the expression that's underneath the radical, and we want that to be greater than or equal to 0. That's positive or 0 or non-negative. So let me erase these markings and we'll work out the domain for this example. We're going to take the expression that's underneath the radical, 2x minus 18, and we want that to be greater than or equal to 0. And that's because we're excluding negative values. We're only including positive and 0. And we solve this inequality. So we're going to add 18 to both sides. That's 2x is greater than or equal to 18. Divide by 2 on both sides to get x is greater than or equal to 9. And this will give you the values for the domain. So you can write that domain in set builder notation. We say x such that x is greater than or equal to 9. Or you can write it in interval notation. In interval notation, you would mark 9 on the number line. 9 is included in the domain, so we're going to put a closed circle on 9. And then we also want our function to be, our values, our x values to be greater than 9. And so I would shade to the right of 9, indicating greater than 9. Now to write that in interval notation, we want to write a lower bound of 9 and an upper bound of infinity. And we'll include a bracket on the 9 to indicate that 9 is included in the set. And we always use parentheses on infinity. So this is our domain in interval notation from 9 to infinity. Thank you for checking out my videos. Have a great day.